Okay, now we start a one-way ANOVA. The meaning of a one-way ANOVA. Okay, the meaning of one is one variable. I told you. I told you many times regarding this. Two-way is two variable. Okay, the one variable, one independent variable, and then we see that the relations, not relation, I'm sorry, it's the one dependent variable and then two dependent variable. Okay, so we see that there is the difference in means. Okay, in means. So ANOVA is that the variance, the analysis of variance. Okay, the variance, analysis of variance. So one-way ANOVA is to see one independent variable, two dependent variable. Okay, between groups. But differ from t-statistic. ANOVA is used for the group of two, right? At least three then. Okay, between the group three and relations from one independent variable to dependent variable. Understand that one. Okay. Once we have more than one, if we have two independent variable, two dependent variable, we call this way the two-way ANOVA. So the term 1 and 2 is related to the number of variables. Understand? The number of variables. Okay. So we will go further regarding this. Okay, number of variables. Okay. So now, then another example. Okay, the example show that our assumptions is we have to meet the assumptions. This is a basic assumption: normality and homogeneity, like that. Okay, so later on I will check it again. But now, what is the ANOVA example? The example of the variance to what variance? Independent variance to dependent variance between group groups. Okay, so now I think that this group will be in this case the impact of party rise on France. The impact, this one is our target, right? Meaning that this is the impact is a dependent variable. Okay, this is dependent variable. And then the fertilized, the species of fertilized is the grouping, right? So we called this one. The species of the fertilized may be according to the manufacturing. For example, if I say this one in abbreviations terms, the fertilized manufacturing company A, B, at least C, right? This three company or three product, which is deeper, is none other than that is the what? That is the dependent variable. Okay, that is the typical model of one-way ANOVA. Okay, the one-way is one variable. I told you what effect. I'm sorry. The variable in this is the manufacturing company, right? Manufacturing company. Then the party rise is the party rise. The party rise is none other than this is what? This is the species of party rise is the independent variable, and then impact of this party rise is dependent variable. Sorry, I makes you confused. Dependent variable, right? So, but now we have just one independent variable like party rise. Okay, the party rise, and we have a group. What group? The party rise produce, right? The party rise produce. They can be A factory, B factory, and C factory is a grouping. So groupings, meaning that this is what? Independent variable. And then impact of this party rise is what? That's a dependent variable. Okay? So now we have one factors. The factor of this is the party rise, right? One party rise, one factor. We call this one as a factor. And then we have a target. What is that? Impact of a party rise. So, and also we have a group, the three group, more than three group. The producers, produce number 1, produce number 2, and produce number 3, like that. Okay, so let's arrange this one again. Okay, I can imagine. So we have a factor. Okay, sorry. The factor. The factor is party rise. Okay, party rise, and then we have a group. We have a party rise produce. Okay, that may be group. Okay, and then we have a target. The target is what? The effect of a party rise. So we have a independent variable. We have a dependent variable. Okay, dependent variable is what? Is the target variable. In this model, it is the effect of a party rise. Okay, this is one-way ANOVA typical model. So we see the relations between them. No, not relation. We just know the difference. Okay, we do not know in case of ANOVA. We just know the relation between. Not relation. It's just to know the effect. I'm sorry, difference between two groups, more than two groups. We just see that difference in means. Okay, now let's see that. Now look at this. If you open SPSS, you can easily find that there is the variable imported. This is ID and party rise and grams, right? Okay, this is the grams of some print, right? There's some print in this model. This gram is representing of the print called, right? Maybe some kind of parent. Okay, parent. Anyway, this is the parent. This is partialized. The partialized is this is the manufacturing of partialized. Number 1, manufacturing. Here maybe number 2, manufacturing. And number 3, manufacturing. At least it should be 3. Okay? At least it should be 3. The 3 manufacturing. This is all what? Grouping. This is all group, meaning that this is independent, right? Independent variables. Anyway, gram is the result. It's the representing of effect. The effect is our target variable, right? Okay, so gram represent effect and partialize classify as a producer. Okay, said at least at ANOVA mother we have more than 2, at least 3. Okay, 3. So 3 group, but we have what? We have only 1 factor. Which factor? The factor name is what? Partialized producers. Okay? Okay, so now I arrange again. Okay, the minimum requirement to run one-way ANOVA. At least we have more than 2 groups. So at least we have 3 groups. Okay, also we have just 1 independent. The 1 groups. I'm sorry, 1 independent, meaning that the fertilizer produce. Okay. Fertilizer produce. Okay. The fertilizer produce is another word. This is independent, right? Independent. Also, we have a dependent variable. Is a effect of okay, this effect of fertilizer, right? Effect of fertilizer. Like this. Okay, at least we have to meet this minimum. Okay, now let's go to next step. So you have to remember these minimum conditions. Okay, what should be required as assumptions to run one-way ANOVA? Let's see more. Okay, here you can see that the menu options, and then you go to analysis, right? You go to this is the prior to then. This is to see the histogram. The histogram show you that the relations in figure, right? So you can at glance see that general, relations, which is not the function, but it's not very actual and detailed, but you can just roughly see that whether how is the 2 relation is related like that. Okay, the 2 variables is related, or the safe of the correlations, whatever. Anyway, see that you go to the main menu, and at the pull down menu you go to legacy dialog. Okay, if you go to legacy dialog, there is the histogram. Okay, histogram is some kinds of the figure which is showing that with the bar the relations. No, not relation. Actually, I should be very cautious of you too of using relations. ANOVA is not the analysis, statistic analysis showing the relation between 2 variables. It just to see the difference between 2 variables, whether it is equal or whether it is difference. Okay, it's the main aim of this ANOVA. Right, that kind of analysis is to detect the difference. Okay, difference of what? Difference of mean. Okay, not the relations. Not to see the relations. This is quite different. Okay, the term difference and relations is quite different. So you should be very cautious using that terms. Okay, and then legacy dialogue and the histogram here. And then the histogram, we also have another options to select. To see in detail, we have a variable here and we have a columns here. Okay, in variable, we have to move our dependent variable here, and in the column, we have to move independent. Okay, so we see the relation between the fertilizer use or not use. Okay, and then the relation between the weight in grams of a parsley plant, like that. Okay, once we use the fertilizer, whether there is some growth or weight variations, okay, in average, like that. See that? Okay, so we see these two relations. So with the legacy dialog, we can find it easily using histogram. Okay, this is for your reference. Okay, this is not the main thing. So you just see, prior to run the program. Okay, roughly you can detect the relations. Okay, before you run the real things. Okay, then let's see that. This is a histogram. Okay, we classified the three section here. Look at this. Here is the none, meaning that not used at all. Not used at all. Okay. Biologically, chemically. We have different types of fertilizer. One is biological and one is chemical. Okay. Once you use the different ingredient, we can detect the grams. I mean the dependent variable, the result, which can be. So we can easily detect whether there is difference between two, right? This is none. This is a biological fertilizer. This is a chemical fertilizer. Okay. Whether we can see the difference in gram in weight between two. Okay. So now we check a histogram, and now the next step is inspecting the sample size and means. The sample size and mean should be similar. Okay, similar. That's we called, because why? This is three different groups. So the three different groups, but each group has a similarity in what? In variation. So we call this one homogeneity. Okay? The homogeneity checking is very important, and I emphasize every time revenge is the way to find homogeneity between groups, right? Okay, we have to map these assumptions, homogeneity. This is the way how we can. But this histogram easily makes you detect whether there might be a homogeneity or where there is the variance and normal distributions or like that. Or even you can expect in advance whether there is the difference in mean or not, because this bar of a histogram makes you easily detect the difference between them. Okay, now we go. So this is a result, right? Result, we just see that the distributions, the distributions of result. Here, look at this. We have a very similar number of observations. The samples here, 30, 30, 30. It's very reasonable, okay? And the mean, you might see the mean, okay, and then standard deviations. The mean and standard deviation at glance at this table, it looks like very similar, right? So we go to next. The number of observations is each parameter has the 30, okay, the same number of observations, okay. Okay, it's very reasonable and very desirable. Okay, look at that next. And then, okay, let's go. Okay, WAY ANOVA. What is null hypothesis? The null hypothesis, I always emphasize that. Null hypothesis automatically picks once you make your alternative hypothesis. Your hypothesis is alternative hypothesis. Alternative hypothesis always emphasize that the difference. Once you emphasize difference by your alternative hypothesis, null hypothesis automatically picks as no difference. Okay? And then, so that's the the things you have to check, right? Normality and homogeneity, right? Homogeneity by the Levin test. And then normality is the once you have more than size 25 or almost approaching to 30, the problem of the normality is automatically solved, right? So we esteem there must be a normality once you cracked your data over 30. Okay, so at least to avoid this issue, normality, you have to gather at least 30 data. Okay. Then regarding the homogeneity, the Levin test. The Levin test is the null hypothesis. I'm sorry. The Levin test is the alternative hypothesis is that what? What? Normal distributions. Now, what is your hypothesis? Not normal distributions. So, to beat Levin test, your hypothesis should be below the point 0.0, right? 0.05. Okay, 0.05. It should be below the result of the phi probability value. Should be below the 0.05, right? Why? Because the Levin's alternative hypothesis is what? No, there is what? There is homogeneity. What is your hypothesis? No homogeneity. So, if you win, the Levin will be rejected. Then what? No homogeneity. Then your data is not available. It's not available. It's not buried. It's not buried to use to analyze statistics, right? So, to test the homogeneity, your hypothesis should be what? Rejected. Okay? To make your data to be homogeneity. Okay? Okay. Okay, here. You have, sometimes you might be very confusing regarding Levin test. Okay? But you have to remember, as all the test is the same, null hypothesis of Levin test is what? Homogeneity. The Levin's hypothesis, Levin's hypothesis is homogeneity. What is then your hypothesis? Your hypothesis is not homogeneity. Okay. Now let's go fast to finish this one-way ANOVA. Again, one-way ANOVA is to see the one independent variable. Here, the one independent variable, the fact. Okay, fact is the fertilizer. Just one fact is whether you use what kind of fact, right? What kind of your fertilizer. And your target is the efficiency. Effect of a fact. Okay, whether you have a bigger friend or not, like that. Okay, effect of fact. Then you have just one variable to dependent variable. In this case, we call the one way. Okay, but you have two variables, two factors, not only fertilizer. For example, if I make some example, not only for fertilizer, but also water, like that. Okay, or salt, whatever, which is additionally one more factors, one more variable. So we call what? Two-way ANOVA, right? So that's the reasons why we use one or two, because it's depending on the variable number we use. Okay, independent variable number we use. Okay, now, so you have to remember, the terms one way, two way, and you have to remember and you have to realize what that means. Okay, so now actually we will go for our program, how we use it. This is flow chart, so you can make this flow chart for your easy operations. Now this is ANOVA SPSS open, and it's a dialog. Okay, we have a analyze menu, and if you touch to see the pull down, and then you can see that compare means, because why? This ANOVA is likely like t-test. So the only difference between t-test and ANOVA is the number of what? The group. Okay, in t-test there are only two groups, but more than two groups we should apply ANOVA, right? So this is one difference between t-test and ANOVA. Okay, so whether to t-test or ANOVA, we have to test between groups. Okay, so the between groups what? The means, the difference of means, whether two groups or three groups has a difference in means. That's our key point to see and to check. Here, we will see that right here. We have a compare means here, right? And the one-way ANOVA, like this. We check, pull down menu analysis, analyze and compare mean, and we go to the one-way. Okay, the reasons. Okay, we have a factor. This factor is our what? Independent variable. Independent variable. And then this one, dependent variable, is our target. What is target? To see whether the weight in gram of a plant. Okay, whether this is the measuring object. So we call this one is independent list. Okay, so we classify now and move the variable, independent variable, to packed locations, and dependent variable to dependent list. Okay, and then now next to this window, next to this window, the dialogues, we can easily find next to this dialogue the option menu. Okay, we press options. Then you can see that. Okay. Okay, this is the result. Okay, what is the result of this one? So this table you should carefully copy and paste and send to me with the explanations of the result. Make sure to add your explanations of translations of result. Okay, that is very, very important. So now you can see the result. Okay. Okay, here is the groups, between groups and within groups, and you can detect what? The totals. Okay, and then between groups is the meaning of between groups, whether there is the difference in means between groups, right? This is our original targeting to measure. So we see the result of this one. Okay, sum of squares. Okay, degree of freedom, mean squares, and F statistic and p-value. This one, okay, located most right positions. This one is what? P-value, right? P-value. The meaning of p-value is a probability value. What? This is a 0.02. Okay, this is almost 2.8 point of possibility that your hypothesis to be wrong, right? Your hypothesis to be wrong. Okay, this is very, very low rate. So you beat null hypothesis, right? What is null hypothesis? There is no difference. Okay, there is no difference between species of fertilized. But actually, your results say that there is a difference between species of fertilized, right? According to the fertilized, the gram of plant is deeper. Okay, meaning that contrary, the fertilized indifference makes a difference in terms of growth of plant right there. Okay, this is the result, and we have to read and then translate this one. Okay, so you have to classify this table. Okay, then you can report. As you copy this one, okay, if you press on the right click, then you can have an option copy this table, and you can copy by clicking and then paste it on your reporting paper and send to me. Use the MS Word as your report sheet. Okay, and then name it, and then send to me by email. Okay, thank you.